Welcome to the Virtual Tutor Series on Core Mathematics for Senior High Schools. This is part 2 of the lesson on Simplification of Algebraic Fractions. In this episode, we cover multiplication and division of algebraic fractions. A prior knowledge of multiplication and division of algebraic expressions, as well as expansion and factorization of algebraic expressions, is key to grasping this topic. It is therefore advisable to watch our video lessons on these topics if you haven't done so yet. As always, take your book and pen as you follow along. We begin with multiplication of algebraic fractions. We can multiply algebraic fractions using the following steps or procedures. 1. Factorize individual expressions where possible. 2. Cancel out common factors. And 3. Multiply the numerators and denominators. For example, simplify the following expressions. Solution. Number 1. 8x squared y cubed over 3xy times 12xy squared over 8y. Step 1. Factorize individual expressions if possible. Looking at the expression, it will be advisable to factorize the numerators and leave the denominators intact. So for the first fraction, we can factor out 8y to have 8y into bracket x squared y squared bracket closed over 3xy. And for the second fraction, we can factor out 3xy to have 3xy into bracket 4y bracket closed over 8y. Step 2. Cancel out common factors. So 8y cancels out 8y and 3xy cancels out 3xy. Step 3. Multiply the numerators and denominators. For the numerators, we have x squared y squared times 4y to be 4x squared y cubed. And for the denominators, we have 1 times 1 to be 1. So our final expression remains 4x squared y cubed. Example number 2. 25x squared minus 9y squared all over 6xy times 18xy over 5x plus 3y. The square root of 25 is 5 and the square root of 9 is 3. So the first fraction can be rewritten as 5x all square minus 3y all square all over 6xy times the second fraction 18xy over 5x plus 3y. For the first fraction, 5x all square minus 3y all square is a difference of two squares and can be factorized as 5x minus 3y times 5x plus 3y all over 6xy. (18xy) in the second fraction can also be factorized by bringing out 6xy. So we have 6xy into bracket 3 over 5x plus 3y. At this point, we can cancel out the common factors. So 5x plus 3y gets rid of 5x plus 3y, and 6y gets rid of 6y. 5x minus 3y multiplied by 3 is 3 into bracket 5x minus 3y, bracket closed. Fantastic. Let's move on to division of algebraic fractions. The procedure is similar to multiplication of algebraic fractions, except the introduction of an additional step. So, the first step is to multiply by the inverse of the divisor. The second step is to factorize individual expressions, if possible. The third step is to cancel out common factors. And the fourth step is to multiply the numerators and denominators. Let's consider the following examples. Simplify the following expressions. Solution. Example 1. 2r exponent 2 over 7p exponent 3 divided by 4pr over 14r exponent 2. The expression that comes before the division sign is called dividend, and the expression that comes after the division sign is called divisor. In this expression, 2r exponent 2 over 7p exponent 3 is the dividend, and 4pr over 14r exponent 2 is the divisor. The first step, therefore, is to change the division sign to multiplication sign by multiplying the dividend by the inverse or reciprocal of the divisor. The inverse or reciprocal of 4pr over 14r exponent 2 is 14r exponent 2 over 4pr. So the expression now becomes 2r exponent 2 over 7p exponent 3 times 14r exponent 2 over 4pr. For the sake of simplicity, Let's first multiply the numerators and denominators before factorizing. So we have 2r exponent 2 times 14r exponent 2 to be 28r exponent 4, and 7p exponent 3 times 4pr to be 28p exponent 4r. At this point, we can bring common factors out. We have 28r as a common factor to both the numerator and denominator. So for the numerator, we have 28r into bracket r exponent 3, bracket closed. And for the denominator, we have 28r into bracket p exponent 4, bracket closed. Let's now get rid of the common factors. So 28r cancels out 28r, leaving r exponent 3 over p exponent 4. Example 2. 5x squared minus 5y squared all over 3y divided by x plus y all over 15y. Let's first change the division sign to multiplication. We can do so by finding the inverse of the divisor. The inverse of x plus y all over 15y is 15y over x plus y. So the expression can be rewritten as 5x squared minus 5y squared all over 3y times 15y over x plus y. 5 is a common factor of 5x squared minus 5y squared. So we can bring 5 out to have 5 into bracket x squared minus y squared all over 3y times 15y over x plus y. Now, x squared minus y squared is a difference of two squares and can be factorized as x minus y times x plus y all over 3y. 3y is also a common factor to 15y. So 3y can be factored out to have 3y into bracket 5 over x plus y. At this point, we can cancel out common factors. So we have x plus y cancelling out x plus y, and 3y cancelling out 3y. We are now left with 5 into bracket x minus y, bracket closed, and 5. 5 times 5 is 25. Hence, the final expression is 25 into bracket x minus y bracket closed. Well done. This brings us to the end of today's lesson and the lesson on simplification of algebraic fractions. In our next lesson, we will cover zero and undefined algebraic fractions. Kindly like and share this video and also subscribe to the TVTL's YouTube channel in order to receive notification on future videos. Thank you for watching and see you in our next video lessons.